Alright guys, so we're going to have a look at a little bit of a difficult mock paper question here, again from 2017. Now, this comes up quite a bit of the higher level insert. On the ordinary level insert, I've seen it once or twice maybe, but it's not massively common, but it can come up, and it's quite difficult. It'll be towards the end of a financial maths question. And it's got to do with the AER, or the annual equivalent rate. And the annual equivalent rate is basically the money that you pay back when you borrow money or spend money on a credit card. So if you spend €1,000 on a credit card, you're going to have to pay back a little bit more than that to the banks. So it's about working out the percentage that you pay per month. So if you look here, we have this formula here, right, which is given to us. 1 plus r to the power of 12 is equal to 1 plus I, which is the interest rate, and or is the monthly rate. So we need to figure out what the monthly rate is. That's what we're being asked to do. So what we got to do first of all is fill out what we know. So I know what I is. So I'm going to write down 1 plus 4 to the power of 12 is equal to 1 plus I. But we're told in the question what I is. I is 18%. And what we're going to do is we're going to change it to a decimal as we always do. So 0.18. So I can fill that in here. And straight away I get marks there. So I've already got like a low partial credit, so I could have 3 or 4 marks there if it's a 10-mark question. So we got I plus 0.18. Now, here is the tricky bit. There's something that I think is a little bit unfair at ordinary level. It tends to be more of an honor level question. I want to isolate or by itself. So I want to get or by itself, because that's what we're looking for. In order to do that, I'm going to have to first of all get rid of this 12. So this bracket is to the power of 12. I'm going to have to use our laws of indices there, which are given in your table book. And they are a little bit difficult to understand, some of them. I know we've done some of them before. So basically, if I have a 12 on this side and I want to get rid of it, well, what I'm going to do is I'm going to take this side and put it to the power of 1 over 12. So it's a law in there. So if it's 12 on this side, I can do it to the power of 1 over 12 on that side. And it's in your table book. It's a little rule that's just given, and you just have to know how to apply it. So I'm going to have 1 plus 4 here. That's going to go away. 1 plus 0.18 is 1.18, all to the power of 1 over 12. Okay. Now, I can get rid of my brackets here. I can get rid of those. It's not being multiplied by anything. I want to get over by itself, which means that this 1 here, I'm going to bring over here, so it becomes minus 1. And I'm left with or is equal to 1.18 per 1 over 12 minus 1. What I can do is I can put this into my calculator. So you can put this whole thing into your calculator now. Or you could just work out this beforehand. And when I do that, I get or is equal to 0.013, and it's going 3 decimal places. So I'm just going to put in another one there because this will influence it. 8. And if I want to change that to a percentage, remember, that's a decimal, I want to go back to a percentage. It's going to jump this 2 decimal places, so it's going to be 1.38. In fact, I should probably put it on. The next one's 8. So it's going to be or is equal to 1 point, jump it 1, 2, 3, 8. Now, because that 8 is going to be bigger than 5, that's going to change to 9. So it's going to be 1.389%. And that is quite difficult. That is quite difficult. So what I'm going to do is write this figure to the side here because I'm going to need it for part 2. So 4 is equal to, that's my percentage, 1.389%. I'm going to scroll up. Second part is actually a little bit easier than this. And the second part goes back down to our compound interest again. Now I don't think when I read it, it explicitly says compound interest, does it? So let's just scroll up here. It says find out the Bob will owe on his credit card after 9 months if he does not make any fruit. So it doesn't explicitly say compound interest, which is a little bit, can be a little bit difficult to work out. But what we know is that this is over time. And we know that the time is 9 months and it's the interest that you'll have to pay back. So we can put it together and figure out that it is going to be compound interest, but it does take a little bit of getting used to that. So I'm going to write down the formula, which is given. So F is your final amount is equal to P on 1 plus I being your interest rate of the power of T. P is what we start off with. And I know from the very top of this question, it was €1,700 that Bob owed. So I'm going to write in €1,700 there. I know that the interest rate is this R here. I know it's a different letter for the AER than this, but this is my interest that I pay per month, so it's 1.389. And I know that the time is 9, so it's 9 months because it's done monthly. So you can see it up there, T is 9. And I want to work out how much it's going to have to pay, which is this F here. So I'm just going to sub them in. I'm going to do 1,700 all on 1 plus I, which is 1.389, all to the power of T, which is 9. And I can put that straight into my calculator. So if I put that into my calculator, I come up with an answer of 1924.71. Right. Give your correct answer correct to the nearest euro. So for the last mark, we just got to round this to the nearest euro. So it's 1925. So he owes 1925 after those 9 months. Probably a little bit, maths is a little bit easier than part 1, but it's just figuring out that we're using the compound interest formula is probably the hardest part there.